Continuing with our discussion of section 2.6 on percent problems, we're talking about the idea of simple interest accounts. And this time we've got a little bit of a different problem, and we haven't been given any table or any other support. How do we work this out? We're told a total of $7,000 principal is invested in two simple interest accounts. On one account, the annual simple interest is 1.5%, while the second account has an annual simple interest rate of 2%. How much should be invested in each account so that the interest earned by each account is the same? Well, on the face of it, this seems like a very complicated thing, but we can use our table approach to help us solve this problem. So let's go ahead and do that. I'm going to draw a little table for us to use right here. So get my little pen working right here. The very first thing to do is to label our investments. And we have an investment where we're going to be investing at 1.5%, and another that we're going to be investing at 2%. All right. Now, we use the formula whenever it comes to simple interest that interest is equal to principal times rate. So we're going to kind of write this backwards. We're going to have our principal. We're going to have our rate. So principal times rate is equal to interest. We want to make interest our last column because it's simply easier to see. We normally read left to right, so we're going to set up our formula left to right. Okay, what is our principal? Well, we know that we have a total principal of $7,000 to invest, but we're not told how much we should put in each account. So when this is the case, what we're going to do is we're going to get a total amount by saying, well, let's say I don't know how much I'm going to put in my 1.5% account, but let's call it X dollars. I'm going to put X dollars in that account. How much does that leave me for my 2% account? Well, there's a total of $7,000, so whatever happens right here, we're going to be X dollars less than that $7,000, and we know that that means algebraically the quantity 7,000 minus X as the amount of dollars that we're going to put into our second account. So that's what we write here, minus X. Okay, now our rates, our interest rates, well, that's an easy one. In our interest rate, we just put the decimal form of our percentage. So we're going to put 0.015 for 1.5% and 0.02 for our second account. And what does that mean? Well, if principal times rate equals interest, this graphic organizing table tells us to multiply across. So we're going to take 0.015, and we're going to multiply that by X to get our interest amount in the first account. We're going to take our rate of 0.02, right, that's our 2%, times our quantity 7,000 minus X. Now, the nature of this problem is slightly different than it was in my first one in that we're not being asked, we're not being given a total amount, right? There is no total amount, right, of interest. What we want to say is how much should we invest in each so that the interest earned in each account is the same. That is, we want to show that whatever amount we get here in the first account will give us exactly the same amount of interest as in this second account. Seems like kind of a weird way to set it up, but if we read the problem, then that means we're going to have to take 0.015x, little cough there, and set that equal to 0.02 times 7,000 minus X as the amount invested at this account. So the interest amount in account 1 will equal the interest amount in account 2. All right, so what do we do right here? Well, let's just do the algebra. We've got a nice setup, so carrying this out, we're going to be taking 0.015x. That's going to equal 0.02 times 7,000. If we do that, that's 140 minus 0.02x. We want to isolate our x terms on one side of the equation, so we should add 0.02x both to the left and the right in this particular equation. So we're going to add plus 0.02, you can say 0.020 for the purposes of keeping the decimals all the same. And we're going to find that we get 0.035 times x is equal to 140. Well, if we want to do a division right here, we have to divide both sides by 0.035 to make this happen. So we're going to divide 140 by 0.035 to get our amount. How does that work? Well, just like I was showing you, if I don't like the fact that I have a decimal place here in my denominator, I can get rid of it. I can shift that decimal to the right 3 places. That's the equivalent of multiplying by 1,000. Of course, if I multiply by 1,000 in the denominator, I have to do that in the numerator as well, which means that I'm going to have to add 3 decimal places with some zeros after it in the numerator. So I'm going to actually have 140,000, adding 3 decimal places, divided by 35. And this is at least a little bit easier for us to deal with as far as division is concerned, because now we can take 35 and try to divide that into the number 140,000. Well, 35 certainly doesn't go into 14, but it will go into 140, and we ask how many times. Well, I happen to know that mentally, if I take 35 times 2, I get 70. And 70 is half of 140, so that means I should try to multiply by 4. Well, does that work? 4 times 5 gives us a 20 if we carry up 2. 3 times 4 is 12, plus 2 more is 140. Lo and behold, it's a nice even divisor. And we end up with 0 as our remainder. Of course, we're going to end up with zeros under each of these spaces, so we don't really need to carry out the whole long string of decimal division, other than to say that, well, we definitely will want to put the 3 zeros above the placeholders that we have over here to the right, and therefore what we're going to find is that x is in fact equal to 4,000. So in answer to our question, we would say that at 1.5%, we should invest $4,000. That's x. And at 2%, we should invest 7,000 minus x, which is to say $3,000, in order to make sure that we have the same interest amount in both accounts.